Okay, once you factor, all right, so we get x plus 3, x plus 1. Okay, set it to 0. Notice there's no variable with the 3. There's no solution there. So you get x equals negative 3, x equals negative 1. Okay, so we're going to make the number line. I want you to leave a little bit of space right here. Small, narrow box, just a little bit. Okay, and then we're going to write f prime. That's where your number line is going to go. Okay, and you're going to put 2 tick marks in order for each of your critical numbers. These are your x values here. And we're going to put 2 zeros here because that's the value of the slope. Those are the 0 slope places. Okay, and we're going to fill in slope or f prime values. And that's where you're going to use your calculator. We're going to test the number line, and we're going to put pluses or minuses. Okay? I don't have a calculator. You guys do. So let's go ahead and let's plug in negative 4 and see what we get. 3 times negative 1 times negative 3 is positive. Positive. I don't actually need the number. I just need the sign. Okay? Then I'm going to test a number between negative 3 and negative 1, so negative 2. And I'm just plugging it in to the derivative. Okay? I'm just plugging it into this factored form here. 3 times positive 1 times negative 1 is negative. Okay, and then I'll test something on this side, so I'll pick positive 1 to test. 3 times 4 times 2 is positive. Okay, there's a little box up here because I want you to draw what f of x should look like based on the slopes I just described. Positive slopes, right? The derivative describes the tangent slopes. So tangent slopes are positive. Looks like this. Increasing. A 0 slope looks like this. Decreasing. 0 slope. Increasing. And so what you did is you sketched a picture of f of x without actually graphing f of x. That's a cubic graph. That looks like a cubic sketch. Okay, based on that, okay, we can say f of x is increasing. Now this end of the number line is negative infinity. Negative infinity to negative 3 union negative 1 to positive infinity. The ends of the number line are negative infinity, positive infinity. And so if I want increasing, we're going to say because f prime positive. Okay? F of x, the original graph, is increasing here because f prime is positive. F of x is decreasing here because f prime is negative. I'm just put those 2 sentences in an answer box. Okay? And then we're going to write a sentence about maxes and mins. Okay? X equals negative 3 is a, you can abbreviate relative max because f prime changes positive to negative, which I can clearly see by looking at the sketch that I made right here. Plus to minus. The part I want you to focus on is being able to write the sentence that describes why you have a max or a min. Negative 1 is a relative min because f prime changes negative to positive. And that is the reason, that's justification, that's the reason you have your answer. Sometimes questions will ask you to find zero slopes, right? We found zero slopes before. Now we're going one step further and we're going to list out where all of the other characteristics are happening. But we did it algebraically. I didn't graph that. I didn't look at the graph. I did it algebraically. You don't always get the graph picture. Sometimes you just get information about increasing and decreasing. Okay, turn the page. We have number 2. Okay, so I'll give you some placeholders to fill out the work. So let's do f prime of x, set it equal to 0, find your x's, okay. Okay, and then we'll do one box about a max, and then one box about a min. Okay, see what you get. All right, so 15x to the 4th minus 40x cubed. So as I set it to 0, I'm going to factor out whatever's common. So this divides by 5x cubed. So we get 3x minus 8. Right? Notice that there's a variable here. Every factor that has a variable gets a solution. So I get x equals 0, x equals 8/3. Okay? So I'm going to mark my 2x coordinates. Okay? They have 0, right? This is the value of the derivative, okay, or f prime, which means you're plugging in to evaluate. Okay, so -1, -5 times -11, so that's positive. Okay, right? For function calculator, you can just type in and evaluate. Okay, 8/3 is like 2, so I'm going to test +1. So 5 times -5, so that's negative. And then this is 2 something, so I'll test 3. Oh, 27. Okay, so big. Positive times positive is positive. Once I get my number line, I can very easily sketch what f of x would look like. Increasing, 0 slope. Decreasing, 0 slope. Increasing. Polynomials are smooth, continuous graphs. This one is a 5th degree. Okay, well, this one looks cubic. Maybe there's a couple extra pieces here that I didn't see. There's no turning points. I found all of the turning points. But it could be not as symmetric as you think. That's usually what gives you the bigger degrees. Even though it's still increasing, 0, decreasing, 0, increasing. Okay, so one sentence about a max, one sentence about a min. X equals 0 is a relative max because f prime changes positive to negative. The sentence is exactly the same. It's the x coordinates that are changing here. Okay. So we're going to do number 3 and number 4. Okay, and then we have a different type of example to look at on the back. All right, so here we go. I'll give you some placeholders. See what you can do. F prime equals 0 equals, find your x's. Okay, see what you can fill out. So, 4x cubed, 3x squared, thank you, minus 6x. The common x comes out, yes. And then multiply to 24, add to 3. Not gonna work. So I do get 0, right, from that factor in front. And then I get the quadratic formula. Opposite b plus or minus b squared minus 4ac all over 2a. Just type it in, guys. I don't need radicals. Just type it in and get a decimal. Okay. All right, so this time I have 3 numbers. 3 tick marks. That's okay. Just put them in order. Now it's a polynomial. It likely is switching. Plus, minus, plus, minus. Doesn't have to, but it usually does switch. With what?
Why would someone want to come up with that?
Because they wanted to be able to solve a quadratic equation. Okay, so now that we have our x-coordinates, when you're typing in your quadratic formula, I would suggest trying to type it in all at once. Okay, so negative 3 plus radical b squared minus 4ac. It's very often you lose negatives, okay? Then divide by 8. Okay, there it is. And then I'm just going to go back up and copy. Change that to a minus. Divide by 8. Negative 1.66. Round to whatever seems reasonable, okay? What do you mean? Okay, so if you are still typing in values to evaluate, okay, so we've got a negative 2. Negative 2. Your store button is right here between the 1 and the 4, so I'm going to hit store. And I'm going to say x. That way, in order to evaluate, I can just type it in. X parentheses 4x squared plus 3x minus 6. Negative. Okay, something in here like negative 1. Okay, so I'm just going to scroll up. Change that to negative 1. When your number lines start getting bigger, it's nice not to have to be able to keep typing everything. So negative 1. Okay, scroll up. Enter. Enter. Positive. Especially if you're trying to evaluate with like, oh, between 0 and 0.9 is like 0.5. Sometimes it's hard to evaluate with the numbers in between because of the ones that you get. So let's do this. 0.5 negative. Okay, and this I could try 1. 1's not so bad to evaluate, but we'll do this anyways. Okay, 1. So I get positive. Okay, down, 0, up, 0, down, 0, up. Okay, that looks like a quartic graph, which means I have x equals 0 is a relative max because f prime plus 2 minus. Okay. Now there would be arrows on this graph, right? Because it keeps going. Okay. X equals negative 1.66 and x equals 0.91 are relative mins. They're both mins, just same sentence, okay? Because f prime negative to positive, same reason. Okay, see if you can do number 4. Okay, so let's get a little started. Okay, so I set to 0. I've got the common 3. And then I try factoring. Perfect square, right? So I end up with a repeated factor. So notice there's no variable with the 3 in front, so there's no solution there. You just get negative 3 from each of the factors. Okay, so go f of x, f prime number line, okay, negative 3. That's it, just one tick mark. That's all we have. Okay, so then we evaluate. I guess I could try negative 4. 3 times negative 1 times negative 1 is positive. Right? You don't always need to use your calculator to evaluate, just when the numbers are a little bit tricky or it's a little hard to. So let's try 0. 3 times 3 times 3 is positive. Okay, so it goes increase, 0, increase. So x equals negative 3 is neither max or min, because f prime does not change signs. If I was going to write an increasing statement, because this one's a little bit interesting, it's increasing, 0 slope, increasing. There's 2 acceptable answers depending upon which textbook you open up. Okay? It means I would accept both of them. F of x is increasing. Okay, so the left side of the number line is negative infinity to the right side is positive. So it's increasing negative infinity to positive. Okay. I skipped over the 0 slope. Yeah. Sometimes you skip over the 0 slope because it's a positive slope on the way. As long as the point to the left is below the point to the right, they call it increasing. And so the point right here is below this point, and this point is below that point. That's why they call it increasing. Now, sometimes, right, you'll see this, and they'll just take out the 0 slope. It doesn't matter. They're both right. Okay, it's literally 50-50 on which book you pick up, whether they write the interval like this or like this. They are both correct. It depends upon the definition of increasing that you're reading. Okay? But the reason is still the same. F prime is positive. Okay. So if you're looking at the next example, there's no equations. It means there's nothing a calculator is going to do for you here. Okay, so it's bringing in some of the graphs that we were doing before. Sometimes you don't have the original graph. But notice that we didn't look at the original graph for the first 4 questions. Didn't need it to answer them. Okay, so what we have here is the derivative graph. So the first thing I want you to do is put a big label on that graph. That is the derivative graph. Okay? Looking at the derivative. I still want to make a statement about each critical number, so maxes or mins. Okay? I want to make an f prime number line. Okay. I don't have anything to plug into, though. I don't have an equation to evaluate. So I'm going to ask you, what is f prime of -3? What is its value? Negative, negative, negative what? Because I wanted a value. It means I'm just looking at the graph. I have the f prime graph. I would like the f prime value. Negative. Okay, what about f prime of -2? So notice this, it's matching. I'm not looking at slopes. I have the graph that I want to look at. F prime, this is value of f prime. That's what we're putting here. So the value at -2, 0. The value over here was negative. It's because the number line matches the graph. They're the same level. Derivative graph, derivative number line. Means you're looking at the values. Okay, so then the next 0 is over here at 3, right? These are recording the values of the derivative graph. Same thing as plugging in and evaluating. It's finding the y-coordinate associated with it. So let's test here. We tested -3. Let's test 1. So it's positive. Here we can test 4. It's negative. Positive is above the axes, right? If you want values, positive values are above the axes. Okay. Below the axis are negative values. Okay, so now that I have my number line, the answer, very quick. Now, I like to keep things in order, so I'm not going to draw f of x right here. I'm going to draw it up here. Right? F prime, f double prime. I like to keep them in order, so I don't want to draw what f of x looks like in between two f primes. I'm just going to put it above the graph. So that would be decreasing 0, increasing 0, increasing 0, decreasing. Okay, looks cubic, quadratic, makes sense. Right? Polynomials decrease by 1 degree. Okay, so my sentence, x equals -2 is a relative min because f prime minus 2 plus. X equals 3 is a relative max because f prime plus 2 minus. Notice that I'm labeling everything that I'm drawing. This is f of x. This is the f prime graph. This is the f prime number line. You have original, derivative, second derivative. You have to label what you're looking at. Okay? Go ahead. Let's try number 6. Same prompt. This is the derivative graph. Okay? This is the derivative graph. We want a number line and sentences about maxes or mins, all the critical numbers. Okay, so I got some colors. I saw somebody write this. That was really nice. Labeling where the pluses and minuses are. Okay. And I get, okay, so my zeros. The only tick marks you want are the critical numbers, okay? Which means over here I should be saying something about -2 and +2. Max, min, or neither, right? Just okay, so notice that f prime, they're the same label, which means you just need the values, right? You're putting the values here, which would be plus, minus. Okay, so f of x would look like just a little sketch. I know there's not a lot of room up here. The sketch makes the analysis part pretty simple, so it goes up, 0, down. So I'm going to draw it a little bigger here. Up, 0, down. Oh, maximum. I see it. Like, I see the answer. I'm barely analyzing it because I've got the picture of what f of x should look like. Up, 0, down. X equals -2 is neither. Because f prime doesn't change signs. Is a relative max because f prime plus 2 minus. Now, based on that particular picture, right, we can't determine absolutes very often. You need a lot more information. But I can see that this point is actually the highest point on the graph just based on the picture that I sketched. And so I'm going to put the word absolute max. And that is not something you can always determine. It just happens to work out for this particular picture based on the information that I had. It's the highest point on the original graph. You can't always figure that out. If you look up at the previous picture, notice I had arrows in both directions. Like, I don't know. There is no absolute max or min. Like, sometimes you can't tell, but sometimes you can tell based on the picture that you draw. Okay, last one. And then this will be our last example, and then we'll stop and we'll get you guys started on your homework and your practice. Okay? It's number 7. Okay, there's your setup. I've got a little box for f of x. I've got my values labeled. Values are above, they're below. Make sure that the number line is matching, so I want to record the values. Okay, so we've got, and look at your scale. This was -2, so this is -1. Oh, almost missed that one. Okay, I like to line up my number line with my graph so it's easier to keep track of. Okay, so why not? I can do this in colors. Makes a little easier to see. Down, up, down, down. That's what the graph is going to look like. Down, 0, up, 0, down, 0, down. Okay, so see if I can put that together here. Right, polynomials aren't very they're a little smoother than that, but you get the idea. Notice, because of the arrows, I can't determine absolute mins or maxes because I've got too many arrows in both directions. Okay, but I can write my sentence. X equals -1 is a relative min because f prime minus 2 plus. X equals 0 is a relative max because f prime positive to negative. And then x equals 2 is neither. All right. Go ahead and grab your laptops when you're ready. The name of the task is first derivative analysis. There might be a few open because Black Day is ahead of you guys. Just do the first derivative analysis one. And then as we get towards the end of class, we'll make sure we pick a reasonable due date for that.